Stress-free learning with
Inonyam.
create a better tomorrow. You with the program. Hard work pays off, so come and put it in. No need to wait, let the lessons begin.
May your stomach be flatter and your ass fatter. I don't know if you're a guy, I don't know, man. I don't know. I mean, if you want your ass to be fatter, I mean, that's your own thing, you know? I ain't judging you. That's your thing. So yeah. Okay, boom. Okay, let's get started. Today we'll be doing statistics. Practically your free marks in paper 2. So that's what we'll be doing today. We'll do some revision statistics. So let's get started. Statistics revision. Okay, so mode, right? We have there are three different terms that you need to remember from your grade 11 year. Mode, it's the number that appears the most, right? So it's the number that's repeated the most, right? Or also called most common value. Median is a middle value in an ordered set. So when you order your number from 1 to whatever, right? Your median is the middle value, right? If you come from the left, you cross out all the numbers, cross out 1 on the left, cross out 1 on the right, cross out left, 1 on the left, 1 on the right, until you get to the middle. And that middle value is called the median, right? The mean, or X bar, is the average of all your values. What does average mean? It means that you add all of your values and you divide by the total number of values, right? Just like how you calculate your average grade, right? You add all of your marks and then you divide by how many subjects you have. So, sum of elements divided by number of elements. That's what mean is. The range is the largest value minus the smallest value. Yeah, range is the largest value minus the smallest value. So that's basically what range is, right? IQR is equal to, what is IQR? IQR is interquartile range, right? Interquartile range is equal to Q3 minus Q1. Q3 being the upper quartile and Q1 being the lower quartile, Q1, right? So let's get down to the 5 number summary. What's the 5 number summary? It consists of 5 things that you can use to construct a box and whisker diagram. So 5 number summary consists of the minimum value, which is the lowest value. The lowest value. Of all your values, what value is the lowest? If you have 2 values that are exactly the same that are the lowest, those 2 values are the lowest value. So those ones you list first, right? So number 2, lower quartile, Q1, is the median of the lower half. 25% or 1/4. So in all of your data, the lower quartile is the 1/4 of all your data. So it's right at the beginning, it's the 25% at the beginning. That's where the half is. So it's half of a half. So what's half of 50%. What's half of 50%? 25%. That's how we get to that. And then the median, number 3, is median, which is Q2. It's the middle value. This is 50%. We already spoke about the median. Median is the middle value in an ordered set, in an ordered pair, or in an ordered data set, right? So for your lower quartile and median and upper quartile, your data has to be ordered. So in this instance, so median would be 50%. The right in the middle, the value that is right in the middle of all your data when it's ordered. And the upper quartile, the median of the upper half. So that would be the 75%, the 3/4. So if your half, the top half, is between 50 and 100, half of that would be 75%, which is 3/4. Maximum value is equal to highest value. Maximum value is the highest value. That's not complicated. In all of your values that you have, what value is the highest, right? And from your 5 number summary, you can use that to construct a box and whisker diagram. This is basically the visual representation of a box and whisker diagram, right? And the first value over here, this is just a number, this is just a ruler per se, right? To just measure your things so that they look fine, right? So number 1 in the beginning, with the small little dots at the beginning, that is number 1, your minimum value. So that is the smallest value in your data set. That is 1. And then number 2, 3, and 4 are straight vertical lines. As you can see, to form a box, we need to have lines, right? So number 2, which is the lower quartile, is the first line. Your lower quartile is the first line, right? And then number three is your median. So what value in your data set is your median? These are actual values. So this is like 1, 2, 3, 4, 5, 6, 7. This is an actual ruler, right? And these are actual, you take into account what the value is, and then you just put it a line across where the actual number is. So if your median is here at the beginning there, that's where your median is.
You are given reading time. You should use that. Check which sections you are comfortable with or which sections are easy, and you should start with those ones. Do those first so that you get your confidence up, and also so that at the end of the exam you don't miss out on easy marks because you're stuck on a problem that you could have left and done an easier one.
What that means is also, it means that the mean is greater than the median if your value is more leaning this side, right? So that's number 3. Number four is your upper quartile, your Q3. That's what number 4 is. It's your upper quartile, your 3/4, 75%, right? 2, I said, is what? 25% and 1/4, which is the same thing, right? And then number 5. Number 5 is, of course, your highest value. It's a dot. Dots is to show a minimum value and a maximum value. So that's basically your box and whisker diagram. But you also have to know what it means when that line there, wherever that line is positioned. When that line is positioned, let's say for example, it's positioned directly in the middle between that and that, right? If it's in the middle, it means that mean is equal to the median. So your average, right, which is mean, is equal to your median, which is the middle value in an ordered set, right? So your mean is equal to your median. That's when that line there is directly in the middle between your your lower quartile and upper quartile. So now once you have that, that means the data is evenly skewed or normally skewed. What does that mean? It means that your data is somewhere sitting in the middle. It's not too one-sided. It's directly in the middle, right? It's an average amount of data. It's evenly skewed, right? But when you're smaller and your median is more leaning towards this side, towards your left side, we call that skew to the right. So wherever it is, we choose the opposite side because it's skewed to the right, because that's where the biggest space is, right? So if your line is more to the left, it's skewed to the right. If your line is more to the right, it's skewed to the left. Because if your line is more this side, we have more dots at this side, which makes it negatively skewed, right? So if your data is negatively skewed, if your data is skewed to the right, it's positively skewed, and if your data is skewed to the left, it's negatively skewed. And that is basically some of the things that you should remember on static revision. Let's look at standard deviation. Okay, so now let's look at standard deviation. What is standard deviation? Standard deviation is obtained using this formula here. So whenever they ask you for standard deviation, you know that you have to use that formula there to acquire your values. Most of the time, some of the time, you will not need to use this formula. You can just put that in your calculator. But in the instant where you have to use, let's say for example, like under cumulative frequency and all that stuff, or gyre curves, you might have to end up using that formula there, right? So what is this? This is sum of until n. What is n? N is the number of data points, or let's say for example the number of people, right? And xi is the data that is given to you, right? It's the data that's given to you. Like let's say they say that in a test, the person obtained 25%, another 35%. That's the data that is given to you, right? X bar is, we already know that S is the mean, right? That is the mean, right? So this is our formula. N, number of data points, number of people, number of number of tests, whatever that is, right? So that's basically what it is. That's basically it on standard deviation. But again, what I say, you can use your calculator. If you have a normal Casio calculator, you know you should be able to use that to get your standard deviation. Another thing that's very similar to standard deviation that we can obtain from standard deviation is their variance. So variance is equal to, what is your variance equal to? Variance is equal to standard deviation squared. So you can't find variance in your calculator. Why? Because they expect you to know that to find your variance, you just square your standard deviation. So once you have obtained your, if they don't ask you for standard deviation, they'll just ask you for variance. It means that you have to calculate both the variance and then you can calculate your variance, right? So again, you can use your calculator. Insert video here and picture. Okay, so now let's look at a couple of things like outliers. Outliers, of course, you're bound to have outliers when you have a data set. You're bound to have data that is too far off. Like it doesn't correspond with all the other data, right? Like someone might have gotten 95% in a B class, right? That doesn't, most of the time that doesn't happen. Why? Because they are normally a B class, so they will be in a B class category type of marks, right? And there might be someone who gets 2%, right? That's not normal because that person that's in the B class, they expected to get between maybe 50 to 60 to 70, right? So that there is an outlier too. So you can have an outlier at the bottom and have an outlier at the top, right? So there are two formulas that can be used to determine if it's an outlier, right? So if, let's say outliers. Okay, outliers, right? So it can be an outlier if it fulfills one of these conditions. So when we say Q1, that will be in the lower quartile. That first formula, that's when it's below all of your data. And when we're using Q3, it means that it's above all of your data. So what are we saying? The formula says Q1 if value is less than Q1 minus 1.5 times IQR, which is interquartile range, right? So your formula says if less than Q1 minus 1.5 times interquartile range, then that is an outlier. It doesn't have to fulfill both. It has to fulfill only one of them. And if value is higher than Q3 plus 1.5 times IQR, that means that it's an outlier, right? Note that there's a plus when it's higher when you're using Q3, and there's a minus when you're using Q1, because for Q3, when it's less than, that means below. That's why we were subtracting, because we're saying it's below it's below the 25% mark, and we're saying over here it's above the 75% mark, the one at the bottom, right? So basically, if it fulfills one of these conditions, that value point is an outlier. Okay, one thing to note, right? There's also a thing about drawing ogive curves, right? You have to know how to draw ogive curves or interpret them, because most of the time they ask you to interpret what an ogive curve looks like. So normally this is what it looks like. It might be something like that, right? That's a basic look at what an ogive curve is. So you would have at the bottom here, that is your lower 25%, which is your first quarter, and then you might have over here your 50%, and then over there your 70%. So your 75%, yeah, this is your 50%, and that is your 25%. So basically that's the looks of an ogive curve. And if a data point is below here, what did we say? We said that if it's below the 25% mark, it's an outlier, and if it's above the 75% mark, it's also an outlier, right? Other things to note when drawing these things is you are given, let's say, a table. It says frequency on one, and it says cumulative. Okay, you have frequency. You have frequency and cumulative frequency, right? So what this means is they will not give you cumulative frequency. They will just give you frequency. Let's say they gave you 10, 15, 3, and 7. Right? Those are the values that they gave you. So now you will have to calculate on your own the cumulative frequency, because you will need that when trying to calculate all your values, like your variance, your standard deviation, and all those other points and questions that they might ask you. So how do you get your accumulator frequency? First of all, you add. The first one is the same as the first one, so it'll be 10 and 10 for the first one. And then from then onwards, you add the value that's already there. So this will be 10 plus 15, which gives you 25. So in this region here, it'll be 25. So 15 matches with 25 in the accumulator frequency region, right? And the next one, the 3. Now the 3, what do I do? I'm adding the 10 from above. That's what I did last time, right? So I have to add the 25 from above at this point. So it'll be 25 plus 3, which will give me 28. So I have 28 for that region, for the row that matches with the 3. And then for the last row, it'll be 28 plus 7, which stay right here. Look, focus. Where you going? Come back here. Come back. Where you going? Come back. You're not done. I'm not finished. Okay, go on. Just joking. No, I'm not joking. Come back. Which will give me 35. Right? So that's basically how I'll calculate my cumulative frequency. And this will help me to calculate a lot of other values. So go check out your examples. Go do a bit of revision, because you need to know this. This stuff here is your free marks in your paper too. So you really have to take advantage, because most of this work is calculator work. So you can be ready before you go in your paper. So yeah, so that's basically it on statistics revision. Okay. Boom.